Hello, good morning everyone. My name is Emil Sharazi bin Rosli and my matrix number is TB22027. And today I will be presenting of two types of sensor widely used in the various application, which is this is the capacitor sensor and strain gauge sensor. The sensor play a vital role in the measuring pressure and strain in the different environment and industries. So let's dive right into it. So here's the simple uh simple comparison of the pressure sensor for the capacitive and strain gauge. So here's have five um comparisons for the strain gauge and capacitor. For the first one is the accuracy. For capacitor, so for the capacitive is high and strain gauge is moderate to high. Sensitivity capacitive is very high. For the strain gauge is moderate. For cost, capacitive is moderate and strain gauge is low to moderate. And durability of capacitive sensor is sensitive to environment. And strain gauge sensor is robustness. And range for the capacitive sensor is broad. And strain gauge sensor application to specific environment for the specific range. So, what is the capacitance? So the capacitance is operate based on the change in the capacitance of two types capacitor plate when an object move closer to or further from the sensor. The capacitance of a flat plate capacitor is proportional to the area of the plate. So, um, let's understanding the concept of the capacitance, which is the fundamental principle behind the capacitance sensor is the ability of a system to store charge when a voltage is applied across two of conductor plates. The capacitance value depends on the area of the plates, the distance between them, and the electric material in between. When an object moves closer to further from the sensor, so it's alter the capacitance and which sensor detects as a measurable change. So this is the configurations of the capacitor sensor. So it have a sensing phase, oscillator, trigger circuit, and output switching device. So let's dive into the functionality. So this is the basic um, configurations of a capacitive sensor when the distance of the two types of plate is shown to if the um, both capacitor plates is far from each other, so the charge in the capacitor plate is decreased. So if a capacitor plates is close to each other, the closer to each other, so the charge will be increased. Depends on their distance. So here's the gas as the pressure for the capacitor sensor. So the capacitive sensor will be interact when the gas is pressure for facing for the sensing phase. So the pressure so for the capacitance plate, first plate will be interact and slightly in and slightly go to inside of second plate in the capacitor sensor. So it show the atoms of the electron and proton change when the two type of plate capacitor is proportional to each other, and the charge will be sending to a oscillator. So here's the oscillator. This is the detail of the oscillator circuit in the capacitive sensor. For the application, so the capacitive application is focused on the blood pressure measurement, heat ventilation, air conditioning (HVAC), dialysis machine. So for the first image is focused on blood pressure measurement, and the second image is focused on dialysis machine, and the third one is focused on heat ventilation, air conditioning (HVAC). So for the accuracy, is it shows the nonlinearity, the deviation of the sensor output from the perfect straight line over its range. The second is hysteresis, the difference in the output when the pressure increases versus when it decreases to the same point. Third, repeatability, the sensor ability to produce the same output for a repeated measurement under identical condition. Fourth, temperature effect, how the temperature change impact of sensor accuracy. So this is the sensitivity of the capacitive sensor. So it's defined as the ratio of change in capacitive in the capacitance. So sensitivity have a formula is sensitivity equals to difference of capacitance over difference of pressure. So here's the detail of the what is the um, change of the capacitance. So and also change difference of pressure. For the measurement range, the capacitance formula is capacitance equals to permittivity naught multiplied by permittivity R multiplied by area over direction over distance. So C is for capacitance. eh, Permittivity in a vacuum A is the constant value 8.85 times by 10 the power of negative 12. So permittivity R is the relative permittivity of the material dimensionals. A, also we know the area of the capacitor plates. And D, distance between the plates. So the measurement range, pressure deflection, change of deflection equals to P pressure times by uh, radius over elasticity uh, times by thickness. So the measurement range have a formula, a specific formula is a range equals to P min to P max. P max is a pressure before diaphragm dia, diaphrag, diaphragm failure. P min minimum pressure the sensor can detect reliably. Reliable reliable reliability. So for the strain gauge sensor is definition of the strain gauge sensor is device that convert mechanical deformation into a measurable change in electrical resistance and also allowing the determination of a strain on a structure. So the image on the right, on the top right, is uh the show the strain gauge. So on the bottom is the formula of strain gauge. Is strain equals to total elongation divided by original length. So we go to functionality. So this is a functionality. Operate based on the resistive and geometric effect. When the material they are attached to deform, their resistance change proportionally, and this change is amplified using a Weston bridge circuit to detect even minute deformation accurately. So the application of the strain gauge is focused on piping, railway track, bridge for structure monitoring, shaft, top measurement, and last one is automotive for beam. So let's dive into the detail of the application. So for the piping, is a pipe carrying fluid of or gas experience internal pressure. A strain gauge can measure the circumferential and longitudinal strain to determine the stress due to pressure. Um, this is show the bridge of structure monitoring. So the strain gauge will be applied into the bridge. So this is the legend of strain gauge, where the strain gauge will be attached. So this is a static strain gauge is for this one, this side, and this is dynamic strain gauge. Dynamic strain gauge for this side, and this legend is focused on the sensor, the specific sensor on their characteristic. So next we are going to railway track. So railway track is to determine the weight and distribution of load on uh, freight trains. Also to ensure the compliance with weight limits and prevent overloading. So we have a key characteristic. Three key characteristics is the accuracy, sensitivity, and measurement range. So for the accuracy, so accuracy is use high quality gauge with type of tolerance and ensure proper adhesion and bonding of the string gauge to the test material. Use a well calibrated Weston bridge circuit and data acquisition system. Sensitivity. So for the sensitivity is typically gauge factor, component of sensitivity, piezoresistive effect, geometric effect, appliance of gauge factor, environmental factor, material selection, bridge circuit for enhanced sensitivity. So basically, we just to understanding what is the sensitivity. So the um simple explanation, the typically gauge factor is most metallic strain gauge have a gauge factor of about two semiconductor, like semiconductor strain gauge. Component sensitivity for the physical resistive, change in resistor deformation, uh, and geometric effect, change in length and a cross-sectional area. Application of gauge factor is a high gauge factor value result is in more sensitive measurement. Factor of environment sensitive can be affected by temperature change and resistance might also change in the temperature. Material selection, metallic gauge circuit enhance sensitivity. Strain gauge are typically used in the Western bridge circuit. So on the right side is the focus on gauge factor. So gauge factor is equal to change of resistance of the strain gauge divided by original resistance over strain relative deformation dimension in this. So the measurement range. So measurement range is focused on the temperature effect. So the temperature effect is high temperature can weaken material or adhesive, reducing the effective range. Some gauges are designed for high temperature environment with extended range. For the application context, uh, structure testing, low strain applications such as bridge or building typically measure microstrain. Dynamic testing, higher strain environment such as aerospace or automotive testing may require gauge with extended range. So here's the comparison of capacitance of both of capacitance uh and strain gauge sensor. So it has 7 parameter that I list. So the capacitive pressure sensor for the operating, so the parameter as operating principle, sensitivity, accuracy, pressure range, response time, such an application. So for the capacitive pressure sensor, it measures pressure by detecting change in capacitance due to diaphragm deflection. Uh, and the strain gauge pressure sensor for the protein system operating principle measure pressure by detecting change. Sensitivity is high sensitivity for the capacitor, and strain gauge is moderate sensitivity. Accuracy for the capacitor pressure sensor is high, and strain gauge is high, but both have a um different accuracy. Like a capacitive with excellent resolution for low pressure application, and strain gauge is can be affected by temperature and material properties. Pressure range for the capacitor is suitable for low to medium pressure, and strain gauge is suitable for wide range of pressure. For response times, capacitive is high cost, and strain gauge is relative low cost and widely available. So for size is capacity for the capacitive pressure sensor is compact and lightweight, and strain gauge pressure sensor is slightly bulkier due to strain gauge and Wheatstone bridge security. And last one is a application for the capacitor pressure sensor is for focusing on biomedical device, HVAC system, and precision instrumentation. And strain gauge is focused on uh, industrial machinery, automotive, and structural monitoring. So that's all for me, and thank you.